Hello, Matrix. Let's talk about how stochastic gradient descent works, and by the end of this video, you'll understand the basics and the pros and cons, as well as some best practices to make the most of this powerful optimization technique. So, let's dive in. Stochastic Gradient Descent, or SGD, is an optimization algorithm used in machine learning, especially for training deep learning models. It's like a GPS for finding the best solution to a problem, but instead of giving you turn-by-turn directions, it points you in the right direction based on your current position. In the context of deep learning, we often deal with large datasets and complex models. Our goal is to find the best set of parameters or weights that minimize the error between our model's predictions and the actual target values. This error is also called the loss or cost function. Now, imagine you're at the top of a hill and your goal is to reach the bottom. You can't see the entire hill, but you can feel the slope under your feet. You take small steps in the direction of the steepest slope, adjusting your path as you go until you reach the bottom. That's essentially how SGD works. In each step, SGD calculates the gradient, the slope, of the loss function using a small, randomly selected batch of data points, instead of the entire dataset. This is where the stochastic part comes from because it introduces some randomness into the process. The pros of SGD include speed, because it uses a small batch of data at each step. SGD is much faster than methods that use the entire dataset, making it suitable for large-scale problems. Noise. The randomness introduced by SGD can help escape local minima, which are like small valleys in the loss function that aren't the true lowest point. But SGD also has some cons. Convergence. SGD might not converge to the exact minimum, but rather oscillate around it. This can be partially mitigated by using a learning rate schedule, which reduces the step size over time. Sensitivity. SGD is sensitive to the choice of learning rate and batch size, which can impact how fast and how well the model converges. To make the most of SGD, here are some best practices. Learning rate. Choose a suitable learning rate or use a learning rate schedule. A high learning rate may cause the model to overshoot the minimum, while a low learning rate may take too long to converge. Batch size. Experiment with different batch sizes. A larger batch size can provide a more accurate estimate of the gradient, but it will be slower and consume more memory. Momentum. Use momentum to help SGD escape local minima and converge faster. Momentum is like a rolling ball that gathers speed as it goes downhill, helping the algorithm to overcome small obstacles. Regularization. To prevent overfitting, use techniques like L1 or L2 regularization, which add a penalty to the loss function based on the size of the weights. So, that's a quick overview of stochastic gradient descent. By now, you should have a solid understanding of the basic concepts, pros and cons, and some best practices to apply when using SGD in your own projects. Keep experimenting and refining your approach to get the best results, and don't forget to share your successes and challenges with the Matrix community.